The photoelectric effect refers to the emission or ejection of electrons from a metal surface in response to incident light. Energy contained within the incident light is absorbed by electrons within the metal, giving the electrons sufficient energy to be knocked out of all the electrons formed within the surface of the metal. Einstein in 1905 proposed that the incident light consisted of individual quanta called photons that interacted with the electrons in the metal like discrete particles rather than as continuous waves. For a given frequency or color of the incident radiation, each photon carries a energy E h mu, where h is the Planck constant and mu is the frequency. For the emission of electron from metal surface, h mu is greater than phi naught. This shows that the greater the work function phi naught, the greater the threshold frequency needed to emit the electrons. The more the number of photons available, the more the number of electrons absorbs energy from the photons, and therefore greater is the number of electrons emitted from the metal surface. We know that K max equals to EV naught and K max equals to h mu minus phi naught. So our h mu minus phi naught equals to EV naught. V naught equals to open bracket h over E close bracket V minus phi naught over E. If we plot a graph between mu and V naught, taking mu on x-axis and k max on y-axis, the graph is a straight line since equation is of the form y equals to mx plus c. The slope of the line will be m equals to h over a, which is a universal constant. What is light? Is it a collection of waves or particles? The answer is both and neither. Light seems to behave as one or the other depending on the situation. When light energy propagates, the wave must be used. When the energy interacts, the particle model must be used. In matter waves, de Broglie suggested that matter also showed wave-particle duality. This was an amazing unifying idea in physics, that is, everything is somehow the same. Light and matter are both things that can sometimes be considered as a collection of wave particles and sometimes as a collection of particles. The wavelength of matter is given by lambda equals to h over b, where our lambda is the wavelength, our h is the Planck's constant, P is the momentum. Photoelectric cells. These are devices whose electrical properties are affected by light. They are used in cameras as light meters, in television cameras, in the audio part of a cell phone, in solar batteries, and in electronic ignition circuits. These are various devices that can be used to measure the intensity of incident light. Photoemissive cells. Light falls on a sensitive surface and electrons are emitted, the number of photoelectrons produced being proportional to the intensity of the incident light. Photovoltaic cells. Light is incident on a positive-negative junction, also known as p-n junction. Essentially, a photodiode and electron hole pairs are produced, giving a small potential difference PD across the junction. The phototransistor is simply a junction transistor in which the light is able to to fall on the base region, producing electron home pair photoconductive cells, in which the resistance of the cell changes due to light. One very common type of photoconductive cell is the light-dependent resistor, LDR. The Broglie equation is given by E equals to Hc over lambda, where our E is the energy, our H is the Planck constant, our C is the speed of light, and our lambda is the limit length.